Welcome to this lecture series on vibrations. This is a complete course in vibrations where we shall learn about the underlying mathematics of vibration, linear algebra, integral transforms, statistical analysis, signal processing. In the physics of vibrations, we will learn about vibrations and wave equation, action and Noether theorem, multiple degree of freedom systems, and of course the vibration of continuous systems. Apart from that, we learn the experimental modal analysis technique, frequency response function, impulse hammer technique, data acquisition and processing, and modal assurance criteria. In the chapter on mathematics of vibrations, we shall use graphical animations to simplify the subtle information hidden in these formulas. For example, if we represent Fourier transforms in a graphical way, we can see that a pure cosine wave, when multiplied with the Euler's formula, leads to the wrapping of the cosine wave on the function. And if the frequency of the input wave matches with the frequency of the Euler's formula, we get a circle, and the radius of this circle in a way gives us the feel of the proportion of energy in that particular frequency. We shall cover the genesis of these mathematical tools, why they were invented, and how they can be used in a creative way in fields other than vibration. We shall also cover some topics related to signal processing and get a feel of concepts like the uncertainty principle associated with information in time and frequency domain. We shall see concepts like eigenvectors and eigenvalues. How were they created? Why were they invented to solve certain set of equations? We will learn how to discretize continuous structures and what is the methodology used to ascertain the modal frequencies and mode shape associated with these structures. We will get a visual understanding of what eigenfrequencies and eigenfunctions in the domain of vibration look like. In the physics of vibration, we will learn how to model structures and try to visualize the solutions through these derived governing equations. We shall evolve intuition for concepts like probability distribution of energy in various modes. Energy, when imparted to a structure, has a tendency to go into certain modes of vibrations. Why is that? We will learn certain concepts like this in the course of this lecture series. In the experimental section of this lecture series, we shall learn about various experimental methods used to ascertain the modal parameters like the mode shape, modal frequency, and damping coefficients. We will learn how to design these experiments, how to sample data and represent it in a way where we can retrieve as much information about the process as we can. In this section, we will use readily available and cheap hardware so that you can replicate these experiments yourself. In this initiative, we have a number of other workshops presented in both English and Hindi language. For more information and queries, please contact us. And of course, don't forget to like and subscribe this channel.